Good morning everyone. Welcome to the next lecture. Today we will discuss input-output analysis as an application of metrics. See, before we are going into the detail of application part of input-output analysis, we must understand what actually the input-output analysis means and discuss the basic concepts and assumptions related to the input-output analysis. So the input-output analysis is one of the most widely applied analytical framework in economics. It is a method which is systematically quantifying the mutual interrelationship and interdependence among the various sectors of a complex economic system. In practical sense, we can say that the input-output analysis may be applied to the various economic problems like a nation or even the entire world of the economy, or as a small economy or maybe metropolitan area, or even a single enterprise's case. We can apply the input-output analysis. In all the cases, the approach is same. The structure of each sector's production process is represented by the appropriately defined vectors of structural coefficient. We will discuss what actually the structural coefficient is. That actually describe the quantitatively the relationship between the input it absorbs and output it going to produce. So actually the input-output analysis discuss the interdependence among the various sectors in a given economy, which is described by a set of linear equation expressing the balance between the total input and aggregate output of a commodity and services produced and used in the course of one or several period of time. So accordingly, we will discuss what actually the history behind the input-output analysis. See, the input-output analysis is also known as it is inter-industry analysis. And the original idea for the input-output analysis, which can be traced back to the early work of British physician and Oxford professor, that is William Petty, in the mid of 19th century. And the first historic breakthrough was made by the Russian-born US economist, that is W. Vasily Leontief, in the late of 1930s, for which he received the Nobel Prize in Economic Science in 1973. So the basic idea behind the input-output analysis is quite simple to understand. See, the economic system is like a fisherman's net. That is, each sectors of the economy is interconnected with each other. So in order to avoid the bottlenecks in the economy, the total output of each producing sector must satisfy the total demand for its product. And as the output of one industry is either used as an input of the another industry or for the final consumption by household, government, net exports. So the input-output analysis is an economic model which actually analyzes the interdependence or interrelationship among the different sectors of the economy, where one commodity is become the input for the another commodity, which will also use it for the final demand. So here we are going to discuss some of the basic assumptions behind the input-output analysis. See, as a model is the simplest representation of a reality. The discussion of model requires some sort of assumptions, and in order to simplify the reality, which may be the complex system in the actual life. So first we will list what are the major assumptions of the input-output analysis. See, the first one, that is the national economy, is subdivided into n plus 1 sectors. N plus 1 sectors in the sense that, see, n industries, that is the n producing sectors are there, which shows that there is an inter-industry demand, or it is also known as it is intermediate demand. And the n plus 1, that is plus 1 is item is nothing but it is the final demand sector. We are going to divide the national economy into two main parts. One is the output of the one commodity will be used as an input for the itself and maybe other commodities, and also used for the final consumption purpose. The second assumption is that the total output of any industry is capable of being used as input in the other industries, or maybe by itself and by final demand sector. So for three purposes, one commodity is using, that is input for itself, then input for the other commodities, and these two are integrated together, and we can say that it is inter-industry demand or intermediate demand. And finally, it is also used for the final consumption purpose by the household and government. See, the third assumption, that is there are no joint products. Each industry produces just one product. It means that no process that produces more than one product. Similarly, another assumption, that is constant return to scale. For the simplifying the theory, we assuming that the production function is having the constant return to scale. And this assumption actually pointed out that if all the input to the production process is increased by a certain proportion, then the output will also going to increase by the same proportion. In otherwise, we can also say that doubling all the inputs will result in the doubling of output. So one of the implications of this particular assumption, that is constant return to scale, that see each producing sector satisfy the property of linear homogeneous production function. Another most important assumption of input-output analysis is, see the combination of inputs are employed in rigid fixed proportion. So for the simplicity of this particular analysis, it is assumed that the combination of the inputs are employed in a rigid fixed proportion, which means that there is no substitution between different materials or no technological progress is going to happen. In the case of input-output analysis, we have a L-shaped or kinged isocone in the case of input-output analysis. So this means that there is an absence of substitutability of the factors. The inputs are employed in a rigid fixed proportion. And finally, we have another assumption, that is there are no external economies or diseconomies of the production. It means that the amount of input required to produce 1 unit of output remain constant over the period being analyzed. So these are some of the major assumptions while we were going to discuss about the input-output analysis we are assuming. Now we have a types of input-output analysis. An input-output model can structured either in a closed or in an open form. So accordingly, we have two models. One is closed input-output model and another one is open input-output analysis model. See, the first one is closed input-output analysis model. See, the output of the sector is equal to the sum of inputs in the other sectors, including the sector itself. See, here it is closed one in the sense that the output of the any sector will be used as an input for the itself, and it is used as an input for the other sectors as well. And it include only, that's why we are saying that it include only the intermediate demand, or we can also say that it is inter-industry demand. And there is no final demand in the case of a closed input-output model. So in a closed form, the entire production is consumed those participating in the production process. That means it is used for the intermediate demand. Then as against the closed input-output model, we have open input-output model as well. In this case, the output of the sector is equal to the sum of inputs in the other sectors, including the sector itself, and also we are going to add one more sector, that is known as it is final demand bill, or it is final demand sector. See, the difference with the closed one is that it has an additional exogenous sector in terms of final demand bill. So this is a exogenous sector, or which we can say that it is an exogenous sector supplies primary input factors such as labor services which are not produced by end industries, or the sector and consume the output of the end producing sectors. So here we are generally including final demand sector as well, that is the demand by the household sector and government sector. So the basic difference between the closed input-output model and the open input-output model is that in the case of open, there will be an additional final demand vector, that is the final demand by the household and the government sector. Now there are certain basic terminology in the input-output analysis. See, the input-output table, or we can say that a transaction matrix. An input-output table actually describes, see, the flow of goods and services between all the individual sectors of the national economy over the stated period of time. Say for example, we can say it is 1 year. See, it is actually showing the interdependence or the interrelationship among the various industries. See, another one is we have an input coefficient or technical coefficient, or it is also known as it is coefficient matrix. See, the input coefficient actually shows that the number of unit as the input of any industry's output needed to produce 1 unit of output of the another industry. So the proportion here is actually showing how much proportion of the output of one industry is used as an input for the producing another sector or another industry. So which is captured through the input coefficient, or it is also known as it is technical coefficient. Now here I am showing the input output table. See here, the input output analysis is actually based on the input output table, which consists of, we have several rows and equal number of columns are there. Every row is actually explain the output distribution of a particular sector. And every column which I am showing here, see, it is the input requirements, or it is the input used for the production by that particular sector. So the input output analysis actually tell us the structure of inter-industry relationship in an economy, as well as how the output is disposed among each industry. So there are n sectors in an economy labeled from it is 1 to n, and the table is here actually illustrate the interdependency between the different sectors of the economy, and each sector requires the input from the other sectors to produce its output. And this intersectoral linkage is actually capturing this technical coefficient. So here the value of matrix shows in the proportion of output from each sector that is used as an input by another sector. See here, in the given table we have two interpretations. One is row-wise interpretation and another one is column-wise interpretation. The first row is nothing but we can say that it is column headings, and the second row is column numbering is showing here. And the real story which is actually starting from the third row. See, the row here indicate the proportion of output from the other sector that are required as an input by the sector 1. See here it is sector 1. So here X11, this X11 means that the X1 is actually the amount of the total output of first producing sector, and here the X11 is the amount of output which is used by first producing sector as input itself. It is the output of the first sector and how much they are using the input for the producing the same sector. And here X12, what is X12 showing here? It is the amount used by the second producing sector as their input, and if you go up to the n producing sectors here, X1n, and here it is showing it is D1, which is the amount of output which is used for the final consumption by the household and government. And this X1 is showing that it is the total output. So the total output of the first industry, which is used as an input for the first industry, which is used as an input for the second industry, and up to n industries are using the output of the first industry as an input. So this is the row-wise interpretation. We can say that, for example, X21, that is the output of the second industry, is used as an input for the first industry. Similarly, X22, which is showing that the output of the second industry used as an input for itself, that is for the second industry, and up to n industries it is using, and D2, which is showing that the output of the second industry used for the final consumption purpose. So this is the row-wise interpretation. Now look at the column-wise interpretation. See, the column represent the sector that uses input or input requirements from the other sectors to produce its output. So since first column here the table shows different producing sectors, that is X1, X2, these are the different producing sectors of an hypothetical economy, which actually shows names and labels in the producing sector. Now from the here we have n number of producing sectors are there. We have n number of producing sector, that is up to X1, X2, up to Xn, that is n number of producing sectors in the hypothetical economy. Coming to the second to up to fifth column, see, it shows that output distribution of producing sector among the economy. The second column, that is here, that is X1, it is shows that the output of the X1 is produced. How the output of the X1 is produced? See, otherwise we can say that what are the input requirements? See, what are the inputs used for the producing X1? See, the first producing sector has used, for example, X1 is used, X11, X21, X31, up to Xn1 amount of input from the industry 1, industry 2 and industry 3. So in this way we can interpret. For example, X2, for producing X2 output, they are using input from the first industry, they are using the input from the second industry, and they are using the input from the third industry, and up to n industries are there. So in that way we can interpret the remaining up to n producing sectors we have. Similarly, we have the 3 to up to 5, we have the same interpretation we can use for this all these columns. So this sixth column here, it is representing for the final consumption demand. So this sixth column is actually showing how much total output is consumed by the final consumer. Last column, that is showing the total amount of output produced by a concerned sector. So there is nothing much on the sixth and seventh column in the input-output analysis. The major player in the input-output analysis values in the, it is from the second to fifth column. And thus from the above discussion, what we can say that the column shows the production function of a corresponding producing sectors. So accordingly, we can say that, see, X1, that is the output of the first industry, that is X1, is the function of X11, X21, X31 up to Xn1, which shows that the functional relationship between output of X1, that is X1 is the output of the first industry, which is the function of various inputs, that is x11, x21, x31 up to xn1. So x1 here it is representing the output of the first industry. Similarly, we have x2, which is the function of x12, x22, x32 up to xn2. That means the x2, the output of the second industry or the second sector is the function of x12, x22, x32 up to xn2. Similarly, we have the third output or third industry, which is the function of x13, x23, x33 up to xn3. And we can extend this is up to n industries. So the nth industry, that is xn, that is output of the nth industry is the function of x1n, x2n, x3n up to xmn. So this is the system of equation actually, which showing how the output of the each sector is depending upon the input they receive from all other sectors. See, all these are the inputs from the other sectors. X11 is nothing but it is the input from the same sector. And remaining all are the taking the input from the other sectors of the economy. So it captures actually the interdependencies or interrelationship between different sectors of an economy. Now here we can say that the x1, that is the output of the first industry, which is equal to x11, x12, x13 up to x1n plus d1. What it is actually showing? See, in this particular framework, the output of the each industry, for example here it is x1, is equal to the sum of its intermediate demand. See, x11, x12, x13 up to x1n, which is actually showing the intermediate demand. That means the output of the first industry, which is used as an input for the first industry, input for the second industry, input for the third industry, up to input for the nth industry, and the part of its output is also consumed by the final consumer, that is captured in terms of D1. So it is up from x11 to x1n, it is actually showing the intermediate demand or it is inter-industry demand, and D1 is actually showing the final demand. Similarly for x2, see here what x2 is showing. X2 is the output of the second industry, which is used as an input for the first industry, input for the second industry, input for the third industry, and up to n industries plus D2, that is for the final demand. For example, similarly we have the X3 as well. That is the output of the third industry, which is used as an input for the first, second, third, up to n industries, and D3 is actually showing it is the final demand. So this is, you can extend up to n industries, xn, which is equal to xn1, that is the output of the nth industry is using as an input for the first industry, second industry, third industry, and nth industry, and also dn, that is up to n industries, or it is final demand of the n industries. So this equation is actually showing the output is equal to the sum of intermediate demand, or it is intermediate inputs, and this D1, D2, D3 up to Dn, which is showing that it is the final demand. So this equation, see here it is showing, we are concluding this particular derivation, that is xi, that is the output of the ith industry, which is equal to the sum of xij plus di from j, which is starting from 1 to n industry. That is the jth 1 to n industry. So here this equation is actually explain how the output of the ith industry or ith sector is used in an economy. See here xi is actually representing the total output, or it is the production of the sector I, and this output, that is the output of the ith industry or ith sector, which is include both intermediate output. See xij, this is showing the intermediate output used within the sectors, and di, which is showing for the final demand for the sector's product. So here xij is actually showing the intermediate demand, or it is inter-industry demand, and the output of the ith industry. See the output of the ith industry, which is used as an input for the jet industry or jet sector. So the sum is here signifies that the sector which is I utilizes its input for all the other sectors which is starting from 1 to n. And here Di is actually representing the final demand for the output of the sector I. And the final demand is actually it is consumption, investment, government expenditure and export and import. Now we have an input coefficient as well. See, one of the important assumption of input-output analysis is that it follow a fixed proportion of input in the production function. That is, in order to produce 1 unit of jet sector, the input used of the ith sector must be a fixed amount, which we will denote in terms of, for example, it is denoting in terms of Aij. And if Xj represent the total output of the jet sector, then the total output requirement of the ith will be equal to, see, we can write the input coefficient, that is Aij, which is equal to Xij divided by Xj. See what is here all these things are denoting. Aij, which represents the technical coefficient. This is generally known as it is the technical coefficient. And this technical coefficient, or it is also known as it is the proportional coefficient, indicating the relationship between the output of the one sector and the input requirement from the another sector. And see here Xij. Xij is representing the amount of output produced by the sector I that is used as an input for the sector J. So you can also, and Xj is nothing but it is the total output produced by the jet industry. You can also write it is, by taking Xj into the left hand side of the equation, it will goes to the numerator side. So we can rewrite this particular equation as Xij is equal to Aij Xj, which is the output of the ith sector used as an input for the jet sector will be proportional. See, it is Aij, which is showing it is proportional to the output of the jet sector. So this is having much more important, especially in the coefficient matrix, or it is input coefficient, or it is proportional coefficient. So here the input coefficient Aij is a technical coefficient, or this input coefficient is actually showing the number of units as input of the any industry's output is needed to produce 1 unit of the output of the another industry. Now here we are discussing the input coefficient matrix by considering the input coefficient matrix by using the coefficient, that is A11, A12 along with their concerned output. So here the interpretation of input coefficient matrix does not have much differences in the explanation from the previous table which we are already discussed, that is input output table. Earlier we were explained that producing x1 unit of output, that is the producing sector, was amount of input, whereas now we are explaining in terms of technical coefficient, that is the producing x1 unit of output. See, producing x1 unit of output, the producing sector uses A11 x1, A21 x1, A31 x1 and up to AN1 x1. That is, in order to produce the x1 output, how they are using the proportional input, that is the A11 unit of x1, A21 unit of x1, see A31 unit of x1. So accordingly we can say that this is the proportion, that is A11 x1, A21 x1, A31 x1. It is the unit of the inputs. So which means that A11, this A11 is actually showing the proportion of x1 that is used as an input from the first output of producing sector in the economy. See, A21, that is proportion of x1 used input from the second output of the producing sector, and so on we can accordingly interpret. A12, A22, A32, all these are interpreted accordingly. So A11, A12, A21, A22 up to A1 and A2 and respectively, All these are explaining that is the proportion. How much proportion of a particular output is used as an input for producing that concerned sector. So that is the producing X1 unit of output, that is the producing sector uses A11X1, A21X1, A31X1 and accordingly. Okay. So now whatever we explained in the above table, we are going to explain in terms of the equation. So we have a simultaneous equation here. See x1 which is equal to a11x1, a12x2, a13x3 plus a1nxn plus final demand. So the output of the first industry. So the a11 proportion of x1, a12 proportion of x2, a13 proportion of x3 and a1n proportion of xn is used as an input. That is, output of the first industry is used as an input for the other industry plus the final demand. Similarly, we have x2, that is output of the second industry, which is used as an a21 into x1, a21 proportion of x1, a22 proportion of x2 and accordingly we can say that up to a2n xn plus the final demand. So similarly we have x3 as well and up to xn amount. So the output of the xn, that is an2x1, an2x2, an3, this is an1x1, an2x2, an3x3 up to amnxn plus dn. So this equation we can simply represent, that is the total output of the ith sector, which is the sum of, which is starting from j is equal to 1 to n aij xj plus di. So here xi, which is representing the total output of the sector I. aij, which represent the technical coefficient. This is aij is the technical coefficient, which is indicating that the proportion of output from the sector J used as an input by the sector I. I hope you understand the concept. So here Xj, which represent the total output of the sector J, and summation here it is indicating we sum over all the sectors from J is equal to 1 to n, and Di, which is representing the final demand for the sector ith output. So the equation is actually states that the total output of the sector I is equal to the sum of the product of output of the each sector J, especially we can say that it is weighted by the corresponding technical coefficient of aij, that is how much proportion aij, that is technical coefficient or proportional coefficient, plus final demand, that is for the sector ith output. Now by using this one, we can rewrite this input coefficient table. See here, it is x1, x2 up to xn. This is representing, it is the column vector. This is the column vector representing the total output of the each sectors in an economy. The total output of x1, total output x2, total output up to xn. Where xi is the, it is output of the sector I, which is equal to, we have a matrix here, that is A11, A12, A13 up to A1n, A21, A22, A23 up to A2n, and A1n, A2n, A3n up to ANN. See what is actually this is showing? This is Aij. That means this matrix is representing the technical coefficient or proportional coefficient. So where Aij, this is representing Aij, which is the proportion of the output from the sector J, which is required as an input for producing 1 unit of output from the sector I. So here x1, x2, x3, this is the output of the concerned sector. This is, of course, we can say that it is the column vector. Then plus we have the final demand vector. See this column vector representing the final demand for each sector in the economy. So we have Di, which is the final demand for output from the sector I. So we can denote this x vector for the total output, and we can say here x is equal to ax plus d. If we denote x is equal to the vector for the total output, A is the vector for the technical coefficient. This A is denoting for the technical coefficient matrix, that is this particular matrix we are going to capture by A. Then we have the multiplied with this column vector, that is commodities or the concerned industry or sector, that is X, plus D, and this D is representing the vector of final demand. This is the vector of final demand. We can reduce our explanation, especially in terms of, this entire explanation we can reduce in the form of X is equal to AX plus D, and this particular equation is actually states that the total output of the each sector depending upon its own production as well as the production of other output or other sectors, and we have a final demand. So now if you go for subtract AX from the both side, then this equation will become, see, X minus AX, which is equal to D. Here AX minus AX will become cancelled out, and here minus AX will be added. So it is X minus AX, which is equal to D. So here X is common, we can take the X outside. So what is remaining here? 1 minus A into X is equal to D. And here I is generally denoting it is the identity matrix. Now we can say that we can rewrite this taking 1 minus A, that is into the right side, it will goes to the denominator, it will become the reciprocal, that is 1 by 1 minus A into D, and we can simplify, we can say that it is X taking the denominator into the numerator, so it will become 1 minus A, that is the identity matrix minus the, what we can say, the technical coefficient raised to the power inverse. So it is inverse into D. So we are going to find the inverse of a given matrix, that is identity matrix minus coefficient matrix inverse into D, that is the final demand vector, in order to find out the output of the concerned sector. So here the X is the variable sector, and or we can say that it is the output of the various sectors. D is the final demand vector, and I is the identity matrix, and A is the coefficient matrix. And we can say that this particular coefficient, we can say that it is the Leontief inverse matrix, and identity matrix minus then coefficient matrix, which is equal to Leontief matrix. And if you take the inverse of it, then it is generally known as, it is Leontief inverse function. Therefore, in order to find out the output of the particular sector, we want to find out the inverse, and then inverse is multiplied by the final demand vector, and that is constant matrix. So we already discussed the stepwise procedures to find the inverse of matrix. You know how to find the inverse of matrix? We have to find the determinant value of given matrix. Then we have to go for finding the minor, cofactor matrix, adjoint matrix. Then we are going to find the inverse. Then that particular inverse will be multiplied by the constant sector. Then we can say that it will be the output, that is X. So let me conclude here. We have discussed here what the input-output analysis actually means and its various assumptions, input-output table or technical or input coefficient, and general formula for finding the output of the each industry. We have derived the formula for comprising, the technical coefficient matrix, output vector, and final demand vector. In the next lecture, we will discuss what are the Hawking-Simon conditions, and then we will go for solving the problems related to the 2-sector and 3-sector models. So we will see in the next lecture. Thank you.